Welcome to today's webinar, announcing Amazon Polly, turn text into lifelike speech. Our presenters today are Rafał Kuklinski and Piotr Luławski. Today with us, we also have Victoria, and she will serve as our webinar moderator, engaging with you and answering your questions throughout the presentation while our presenters present. Rafał and Piotr, welcome. The floor is now yours.
Thank you. Thank you for introduction. Welcome everybody. My name is Rafał Kuklinski and I'm leading text-to-speech team. And today I have an honor and the pleasure to introduce Amazon Polly and make the presentation of Amazon Polly, so service which turns text to lifelike speech. Just a few words about my background. I'm a software development manager and my background is in general in software development. And I spent lots of time on building heuristics and building algorithms for image compression, image analysis as well, and on flight planning systems. And for almost 6 years I'm working on the text-to-speech, so on application of deep learning and signal processing for speech synthesis. So, short introduction, what you can expect from this session. Obviously, we'll start from introduction about Amazon Polly, what the service is, why we decided to build it. We'll cover a bit and touch base on few features and functionalities which we are providing with Amazon Polly. I would like to also give you some overview of what's under the hood, what's the technology behind the service. Obviously, I would like to also show you how to get started with Amazon Polly, how to make some speech requests. We also prepared a workshop and demo to show you how you could simply integrate Amazon Polly into your solution. We'll tell a few words about pricing, and last but not least, we are waiting and we are looking forward for your questions. So let's get started. Introduction to Amazon Polly. So why we build this service? We are already providing text-to-speech for a variety of Amazon products. Our text-to-speech is already used on Amazon Fire devices, on Kindle devices. We are also powering Amazon Alexa. And we noticed and we got this, get this impression that speech becomes the natural element of the user interface of applications nowadays. And in fact, the naturalness of the speech is quite critical for the naturalness of the user interface, of the quality of the user interface that we are providing with our application. The second element which we noticed or got simply the information from our customers is that the way how they integrate text-to-speech into solutions differs a lot. So we have customers who are simply streaming directly from the cloud, and that's a good solution for them. We have situations when customers need to either cache speech or store it on the device to serve later to end users. We have also customers, and it's also quite often the use case when they need to record the speech, put or embed on their solution like device or in a movie, for example, and then distribute this content or this product to end users. So we thought that first of all we have all the necessary elements to serve those needs. So we decided to build a service which converts text into lifelike speech because we have the portfolio of natural voices. We also have the portfolio of 24 languages, so we are covering 24 languages, and we have 47 voices. 47 voices across those 24 languages. We build this service with having in mind the real-time scenarios. So we build a streaming service which serves first bytes of speech as fast as possible to support real-time use cases, and this guarantees low latency of responses. Last but not least, we are not applying any restrictions on usage of generated speech in the sense that we do not, we enable developers to store, replay, distribute generated speech according to their needs. So let me cover point on quality of the speech synthesis system because that's critical. As I mentioned, that's a critical element of the naturalness of the user interface or the quality of the user interface. So First of all, the quality is perceived through 3 dimensions. First dimension is naturalness of generated speech, naturalness of generated audio. Naturalness is quite subjective measure. It's about how close generated speech is to real human being. So let me play in a sample of speech.
Alice was beginning to get very tired of sitting by her sister on the bank, and of having nothing to do. Once or twice, she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
I hope it was audible through the network channel. As you can hear, we are generating very natural speech with natural pronunciations and also with the intonation which applies or which is built for the context of the generated speech. How we measure the naturalness to make sure that we are providing the speech which is really natural, we are building a set of blind tests. So for any text-to-speech voice that we are releasing, we are mixing the recordings of real voice talent and the output of our text-to-speech system and asking end users to rate the naturalness of the generated audio. And whenever this rating of the generated audio and rating for the real voice talent or is close enough to rating of real voice talent, then we perceive text-to-speech system as being natural enough to be released. Second dimension of quality of text-to-speech system is accuracy of text processing. The thing is that in the text which we can expect as an input for text-to-speech system, we can expect various text structures. We can expect numbers, acronyms, abbreviations. We can also expect that we will get words which are read differently depending on the context. And obviously end users are expecting that we will be able to disambiguate that, to solve this problem and simply serve the speech like the real human being would do. So let me play 2 samples. That's probably not a temperature in Las Vegas today, but I'm not in Las Vegas, so I might not know. So let me play this sample.
Today in Las Vegas, Nevada, it's 90 degrees Fahrenheit.
So as you are able to hear, we are able to disambiguate or simply solve how the NV should be pronounced. The same with the numbers, acronyms, and from the context, what should be the right expansion of those structures. Let me play another example. So here, please pay attention to pronunciation of word live.
We live for the music, live from the Madison Square Garden.
That's a homography. So I mentioned that some of the words needs to be pronounced differently depending on the context. And that's exactly this use case, exactly this case. And for accuracy of text processing, we are testing the large variety of texts to make sure that we are covering various phenomena like that. Third element of the quality of the text-to-speech system is intelligibility. And the intelligibility is about how comprehensible is text that we are generating with text-to-speech. Let me play one of the English tongue twisters.
Peter Piper picked a peck of pickled peppers.
So honestly, I'm not able to repeat that, but the text-to-speech system is able to pronounce it in an intelligible way, so everybody are able to comprehend every single word. I mentioned 24 languages, so here's the portfolio of languages which we are offering with Poly. Those orange areas on the map are areas where those languages are being spoken, so those are areas which you can target with your application if you are building your user interface with Poly. Few words about features and functionalities of the service. So basically I would like to focus on 2. One is speech synthesis markup language, or SSML. SSML is W3C's recommendation. It's a way to instrument a text and provide some guidance on how the text should be interpreted by text-to-speech system. So you can imagine, for example, that you would like certain word to be spelled out or certain number to be interpreted specifically as a phone number or as a, or simply be spelled number by or digit by digit, depending on the context or depending on your wish. Here I have an example of spelling out my name. So that's the usual case whenever I'm checking in the hotel and I'm getting this question to spell out my name. Obviously, it's a challenge for me because I'm not an English native speaker. So I could use text-to-speech for that.
My name is Kuklinski. It is spelled K-U-K-L-I-N-S-K-I.
So as you can see in the text, what I did here with SSML tags, first I pointed out that my surname, so Kuklinski, should be interpreted as characters, so spelled out. And secondly, I also added a modifier which informs text-to-speech system that it should be read slowly. And SSML obviously is much richer than that. That's just an example, and I will later also show some other examples of use of of SSML. Second functionality which I would like to present today is use of lexicons. Lexicons basically enable developers to customize pronunciation of certain words. You can imagine a use case when we are, for example, releasing a product which we are very focused on how it should be pronounced, or releasing new brand name, or for example figure out the nickname for ourselves, for an artist, which should be spelled out quite specifically. Here I have an example of my daughter's name. That's really my daughter's name. Usual pronunciation in US is more or less like this.
My daughter's name is Kaja.
Which is correct and which is according to US English pronunciation standards, and that's usually the default pronunciation which I'm getting from English native speaker. The thing is that my daughter is Polish, and this name should be read according to Polish pronunciation rules. So what I can do for my account, I can apply a lexical entry like this, which says basically that whatever would be a spelling of my daughter's name, so whether it would be capital letters or no capital letters at all, it should be pronounced in this specific way. And the characters which I'm using in the phoneme tag, those are this is the X-SAMPA, which is a standard phonetic alphabet. And this entry informs text-to-speech system that the name should be pronounced Kaya, and the output is...
My daughter's name is Kaya.
So that's exactly what I would expect and how I would like my application to behave. From now on, every call to Kaya in my application would be simply pronounced like that. So a few words about how the text-to-speech system works. So where's the magic which makes it possible to speak like a human? So main challenges of text-to-speech, I already covered it a bit. So our goal to convert text into intelligible, natural, and accurate speech. Challenges are homography. So I mentioned the live life example here is a similar one. So I live in Las Vegas versus the presentation a broadcast live from Las Vegas. Another one is text normalization, so ability to expand acronyms and abbreviations or other structures. Here is an example which is a text normalization issue and also the kind of homography. So we have st dot, which can be pronounced as street or saint depending on the context. Third problem or third challenge is the conversion of text to phonemes, so-called grapheme to phoneme conversion, or letter to sound conversion if you wish. So please take a look on the example here. I have three words which are theoretically should be pronounced exactly the same or should rhyme simply because the end of the word is the same. But in practice they are pronounced differently, right? There is though, true, tough. And that's a G2P problem, G2P challenge. So we need to build machine learning models which will be able to disambiguate this kind of cases. Last but not least, in the text which you are providing to text-to-speech, you can expect foreign words, proper names, or slang, and all of those elements you would expect that it would be pronounced correctly by text-to-speech system. So how it works? here's the flow. We have a text, so in this case, market grew by more than 20%. We applied text normalization. So basically, we change the sequence of characters into sequence of canonical words, so words from a lexicon of the particular language. Once we have that, and we are able to divide the text into tokens, we can figure out what would be the pronunciation of particular word. So here we apply deep learning mechanism to perform G2P, so to change the letters into sounds. And this particular notation is IPA, well known by linguists or people who studied linguistics. So that's in IPA description of how market grew by more than 20% should be pronounced. Once we know that, we would like to apply another deep learning mechanism or another deep learning model, which is able to figure out what should be the prosody or intonation of a sentence. So here we define what should be the pitch for particular elements of a sentence, for example. Once we have that, we are taking a look into speech inventory. So speech inventory, we basically build a text-to-speech system in a way that we record real voice talent, we record the coverage for particular language, and from this speech inventory we are gathering tiny units of speech, which we can concatenate together, adapt in a way that it will sound naturally. And next we just apply prosody modification, so we modify those units a bit on the signal processing layer just to make it match the prosody contour, the desired intonation. And then we can stream. And the result is?
Market grew by more than 20%.
We're there. I mentioned the fact that we have a speech inventory, so the inventory of audio which is recorded with voice talent. This technique is called unit selection. And so let me cover it a bit. So let's start from what unit selection is. So unit selection is responsible for conversion from phoneme sequence, so from sequence of how something should be pronounced, into a waveform, basically. For that, we need a database of recorded audio. This recorded audio represents various phenomena in the language. From this database of recorded audio, we are dividing this database into speech units, which we will later concatenate. And in our case, unit is a diphone. Diphone is half of one phoneme and half of another, and we are looking for various combinations of diphone or phonemes to cover the particular language. But to make things even more complicated, the thing is that for every diphone and for every phoneme, we have a big number of features which represent the context of the particular phoneme. So please imagine a situation when, for example, we have a phoneme in the proximity of the vowel or consonant. Depending on that, this phoneme will be pronounced a bit differently. One of the examples which we are showing here is allophonic variation. So here we have the combination of P and I, and it can be pronounced differently. It's pin, spin, limping. So depending on the neighborhood, depending on the context of this concatenation, it will be pronounced differently. So we need to have coverage for all those features for diphones in our speech recordings database. To make this happen, obviously selecting it manually would be an overkill. So to make it happen, we are taking tons of texts from various sources. Those are ebooks, news, web content, and from this text we are automatically selecting texts which are covering various combinations of diphones and significant features in the language. So we do it automatically. We cover those combinations which are specific for the language or are possible in the particular language. And out of it, we are generating the recording script, which is a few weeks of recordings. And as an outcome, we have a speech inventory, which is able to, or which we can use to basically synthesize any text you can think of in a particular language. So how it works in practice? Let's take an example of sentence, an apple a day keeps the doctor away. So to synthesize this sentence, we are taking various sentences from our recordings, and here is an example of such sentence. And by the way, that's a real life example, so that's really how we synthesize this sentence. So we have a first sentence which we recorded with a voice talent where we taken N. Then from two other sentences we combine them or combine units from those sentences to formulate apple, a day, keeps, and so on. And concatenating this, we are generating audio, which sounds like that.
An apple a day keeps the doctor away.
So as you can hear, we are concatenating them or building the speech without any glitches or disfluencies in generated speech. So how to get started and how to use this technology, how to use Poly? It's very easy. So we have obviously the Amazon Poly console, and I would like to show you how the console looks like. So let me switch to my browser. So you should be able to see my browser right now. I have here a default text. Let me play it.
Hi, my name is Joanna. I will read any text you type here.
Okay, that was easy. So let's try a few examples of text which we can synthesize. I mentioned homography, which is a challenge for text-to-speech. So how about if I will take this sentence and play this one. Please notice wind and wind.
Lines may wind around the pole if the wind is strong.
So as you can hear, we have the amount of homography in the English language is quite big. So for various homographs, we have models which are able to disambiguate what's the right pronunciation of the homograph. I mentioned the text normalization example, and I mentioned that we have the street and saint possibility. So let's try it out.
St. Mary's Church is on 226 St. Mary's Street.
So here, depending on the context, we are able to pronounce street and saint correctly. Let's try another example. So we have also, I mentioned also the foreign words or the proper names. So here is the few phenomena like that.
Love him or hate him, Gilles Arnaud continues to challenge the zeitgeist, leading the charge towards a new society in Nice, France.
So here we have various phenomena like that. We have Gilles Arnaud, so proper name, which has the French origin, so we are applying the French pronunciation model. We have zeitgeist with German origin. Nice, finally, which is kind of homography, so there is obviously the word in English, which is nice. And we are able to solve that. I mentioned also that proper names and the proper names can appear every single day. So here is an example. I would say that artists are, in particular, very creative. So here's Kesha, which we need to understand that it should be pronounced as Kesha, even if the dollar is inside of it.
Kesha's latest single is True Colors.
Which is exactly what I would expect. Let me show you an example of SSML. So I had one example in the presentation. Let's try something different. So here is a sentence.
Jesus Manuel Corona is a Mexican professional footballer who plays as a winger for Portuguese club Boa Vista.
So here we have Jesus and Jesus, which is pronounced differently depending on what's the origin of the word. Here in this particular example, we would need some additional information to understand what should be the pronunciation of this word. So for this, we can use SSML. So for that, we're just switching the tab here to SSML. And here is an example of the same sentence with SSML tagging, where I'm pointing out that Nina, US English Voice Talent, should pronounce Jesus Manuel Coronas using the Spanish pronunciation, and Boa Vista should be pronounced using the Brazilian Portuguese, or Portuguese, sorry, not Brazilian Portuguese, but Portuguese pronunciation, Portuguese. So here's the outcome.
Jesus Manuel Corona is a Mexican professional footballer who plays as a winger for Portuguese club Boa Vista.
Also, I mentioned that we can use lexicons. So here is the example of of a lexicon. So we had this conversation. We have two developers in the team with last name Nguyen, and we have this conversation between them. What's the right pronunciation of last name Nguyen? So one can be like this.
My name is Nguyen.
Which is correct. There is another pronunciation which is also correct, and it can be preferred. So for this pronunciation, I will upload a lexicon which provides the change of the pronunciation. Let me just select the file. Just give me 1 second. For this I need to find the file. So I'm applying lexicon which changes this pronunciation, and after applying the lexicon it will sound like this.
My name is Nguyen.
And to make this happen, I'm simply applying a lexicon which looks like this. I will show it to you on a screen. So you can notice that you can notice that in this lexicon I'm simply providing the information that Nguyen, doesn't matter how it will be capitalized, should be pronounced as Nguyen, and from now on my application will read it like this. So that's basically how we can use the console. From the console we can obviously save the file save the speech as an MP3 file, or change the format to some other file formats if we wish. Obviously that's a service, so we have also an API which we can use to build an application. And we decided to build such an application for you, to present such an application. And we thought about the use case when we are traveling to work, when we have traffic jams and we would like to maybe read something, maybe try out the blog. And we thought about the example, how about using Poly to voice your favorite blog? And for purpose of presenting this application, I will give a voice to Piotr. Piotr, please go on.
Right. So the problem is actually to voice a blog that's available on the internet. And that can be actually any blog, but in this example I will base on the official AWS blog that's written by Jeff Barr. Let's go through the tools that we're going to use in this exercise. So we'll need an RSS feed that is available publicly in the internet, and again we are working on an example of official AWS blog, but that can be any RSS feed, and that doesn't limit us to blogs. Actually, that can be any news feed or something similar. We'll use Amazon Poly to convert text to lifelike speech. Amazon CloudWatch is a service that allows you to set some alarms, analyze and emit metrics, and at the same time it allows you to set some events, and we'll use it to periodically trigger Lambda. And Lambda is a computing service that can solve many general problems. In our case, it will be used as a kind of an instrumentator, and it will contain logic of the application. And Amazon S3 is widely known storage system. In our case, it will be used to store the generated audio files. So in the first step, Amazon CloudWatch periodically triggers Lambda function, and Lambda is responsible for checking if there is a new content on a pointed RSS feed. If the new content is available, it's sent to Poly in a form of text, and Poly returns the generated speech. The speech in form of audio files, in form of actually MP3 files, is stored in the previously pointed ENS3 bucket, which is set to serve static content over HTTP. So here is the result.
New post. Author, Jeff Barr. Title, CloudWatch Update. Jump from metrics to associated logs. A few years ago I showed you how to store and monitor OS and application log files.
Yeah, so let's go through the exercise. And the whole code and also the relevant documentation and tutorial is available publicly on the GitHub repository that's linked from this presentation. So let me just open the link. How can you switch to the browser? Okay. So you have basically two choices if you want to follow, if you want to use this sample application to voice your blog. You can either download the source code, potentially modify it, and build a package that will be uploaded to Lambda, or you can just go to this folder that I will do at the moment and download ready-to-use package zip, which contains everything that we need. So let's store it somewhere on the disk. And let's switch to AWS console when we will build the whole solution. We will start with S3 and create a bucket that will store a result of our application, so which will store the audio and the podcast XML, which is kind of an index file for the podcast. So let's name the bucket Poly Workshop, and we don't have to change the region. Let's just go with the default US Central. Okay, the name of the bucket have to be globally unique. So let's add like a kind of a number of the postfix. And what we do have to do at the moment is changing the permissions to make sure that the bucket is publicly available. So I'm going to copy the policy from the tutorial, which is again available on the GitHub. And there is a whole README file that allows you to repeat the steps that I'm just describing. And we need to just copy the relevant JSON document that describes the policy for our newly created bucket. And all we need to adjust is the bucket name itself. Let's save the file. And we have to also enable static content after setting the right policy. And we will use podcast XML as the default, as the index document, as this is the standard for podcasts. So, great. We can save that, and we can actually also check if that worked by going to the newly created bucket and just trying uploading sample file and checking if we can access it from our browser. If our browser can access it, most likely our podcast player will be able to access it as well. Give me a second. So let's choose the right file. And after uploading, we try to access it using the browser. But again, normally it will be accessed using podcast player on your mobile device, on your desktop device, whatever. So if you go to properties, we can see the URL that points to the example file. And we can just follow this link. Seems that the file is available, which means that the bucket was configured properly. And we don't need this file anymore. That was just for the test. Normally, it will be generated by the application in runtime. So let's delete that at the moment. Sorry. I have a dialog window open somewhere. Maybe let's just...
Yeah, just give us a second.
Okay, cool. So let's open a new tab. Oh, sorry, I was intending to open a new tab. Let's open a new tab in which we will go through to Lambda and to actually create to actually upload our previously downloaded package downloaded from GitHub. The code uses Python as a runtime, and we can base on the simple hello world application. We will skip the trigger configuration at the moment. Again, CloudWatch will be our trigger, but we'll configure that a bit later. So we have to give a name for our function. So poly workshop should be fine. And again, we don't edit code inline. Instead, we are using the previously uploaded package. And here is the package. So let's open it. And we also need to adjust some other configuration. In particular, we have to make sure that Lambda has access to both Poly and S3 bucket that we just created. So we have to create a custom role, which opens a new tab. And we will copy the role document, JSON document that describes the role, again from the GitHub repository. So we want to create a new role policy. Let's edit the document. Yep, we know what we are doing, so let's confirm the dialog box. And let's just replace the default with the code that I just copied from the GitHub. Clicking allow closes the tab. So let's get back to Lambda. Another setting that we need to adjust is the timeout. So by default, it's just 3 seconds, while Poly is quite fast. It responds in real time, but converting like a content of a whole block and storing it in S3 bucket takes a while. So let's adjust the timeout and let's click next. After reviewing all the settings, and I'm quite sure that the settings are fine, we can create the function. It takes a while as we are just uploading the whole package file. It contains not only the code, which is relatively short actually, but also all the dependencies. For example, I used Beautiful Soup to sanitize the HTML, which in real world scenarios may be not perfect. Wait a second, because I have some... That's weird. Right. So we can. Okay. Let's just download the file once again to make sure that or maybe let's check when is the file. Give me a second because it seems that I was basing on a wrong file. So we should actually use the version from the GitHub. It seems that the file that I've just uploaded was corrupted, but no worries. I'm pretty sure that we can fix it quite soon. Right, so copy and replace. And this file seems to be the right one. Right, so the settings values didn't change. Let's go to the next screen and let's create function once again. So again, it takes a while as we are uploading both the code and all the dependencies. I've mentioned Beautiful Soup and some other utilities that I used as well. You can see everything in the request.txt on GitHub. The function was created, so let's check the solution. As you can see, the bucket contains just the file that I've uploaded previously. So let's configure a new test event to be able to test the function and see how it works. And we have to specify some input parameters for the function. So as I said, it's quite generic. That's why we have to point to the targeted block or any other RSS feed. And we also, as you may expect, have to adjust the bucket name, as any of you will have a different name for your bucket. So if I remember correctly, I use Poly Workshop 20 as a name. And we can save and run the test. So it takes a while, as again, we are downloading and converting the whole content of the blog. We can preview how it works on the S3 bucket. Let's refresh the content. And we can see that some audio files already start appearing in the bucket. Also, the podcast XML will be shortly overwritten with the right file that describes the current content of the bucket. So as Lambda function is running, we can open a new tab and configure the mentioned CloudWatch to make sure that the step that we've just done, which was manual, like triggering the Lambda function, which will be done periodically. So whenever a new post will appear on the observed blogs, it will be automatically converted to audio files. So let's create a new rule, and we'll use schedule as the base for the event, and the default 5 minutes is often enough, most likely for most of the content. We should choose Poly Workshop, which is the name of our newly created Lambda function. And again, in the input parameters, we have to paste basically the same values that we use for configuring the test event. So let's just copy it once again from the from GitHub. And as you may expect, the default URL is fine for my case. You may adjust that in yours, but for sure I have to change the name of the bucket. So we have to also name the event. So again, Poly Workshop works just fine, and we don't have to adjust any other settings. The rule was created. In the meantime, I expect that the Lambda was finished. Yes, execution was finished successfully. So let's go to the S3 bucket once again to see if we have some more files. Seems that this is the case. And most likely, as I mentioned before, podcast was actually overwritten. That was the last step. That's an index that points to all other files. So what we can do at the moment is to go to properties of that file, to copy the URL, and we can also test that in iTunes, which is podcast players, but you can use any other podcast players, any other podcast player available on Android, Windows, iOS, or any other system. So let's type the URL, click OK, and our podcast is downloaded. So let's open any of the newly posts.
New post. Author Jeff Barr. Title opening soon. AWS office in Dubai to support.
Yeah, that's enough for the demo. So this is a source code that is at core of the presented application. For the simplicity, I've removed the part that's responsible for checking for a new content and generating the podcast XML file, as it's not very relevant to the, just to simplify the file. As you can see, what it does now is just synthesizing the sample content, which takes just a single line, and uploading the result into S3 bucket. So summing up the solution. Amazon CloudWatch is responsible for periodical triggers to Lambda function, which causes checking for a new content and downloading content if it's available. The content in form of text is sent to Poly, which is responsible for converting into lifelike speech, and in form of audio files, in form of MP3 files, it's stored in the pointed S3 bucket. So that was just an example. Feel free to download the code, adjust it, and possibly add new functionalities like support for Facebook posts, Twitter messages, or maybe add support for reading your emails to be able to listen them when you are driving or commuting to work. So thanks for that part.
Thanks, Piotr. And after this workshop and the presentation of the service, just a few words about the pricing, about the Poly cost. So Poly is a cost-effective service. Obviously, in pay-as-you-go model, we are charging customers per character, which means that depending on how many characters you will simply send to the service, you will be charged per this amount of characters. Prices, the pricing of the service is $4 per 1 million characters. Obviously, if you send just 100 characters, you will be charged just for 100 characters. And just to give you an imagination, what does it mean, $4 per 1 million of characters? It means that the average news article costs around 3 cents. It also means that if you would like to synthesize the Christmas Carol by Charles Dickens, the cost would be around 66 cents. Or if you would like to synthesize the Two Towers from Tolkien, that's around 15 hours of speech, is a cost of $3.10. Parrot comes also with a free tier of 5 million characters per month for a first year. And this means that with this 5 million characters, every month you are able to synthesize 1,600 average email messages for free, or 770 news articles, or you would be able to synthesize 3 first parts of a Song of Ice and Fire, so a Game of Thrones, a Clash of Kings, and a Storm of Swords for free per month. Last but not least, as we mentioned previously, you can store and reuse generated speech if that's the requirement for your application. And that's it regarding the presentation of Amazon Polly. And we are looking forward for your questions. We already, in the meantime, tried to respond to some of those. We are happy to take other questions.
Great, so we have about 8 minutes left. Please take a quick minute to reply to the polls on the left-hand side of your screen. And at this point, we are going to start taking some of the questions live. We apologize in advance if we don't have a chance to get to all of your questions. Please continue submitting them, and we will be saving the Q&A log after the fact for review if we don't have a chance to answer all of them. Rafael, I'll hand it back over to you.
Yeah, thank you. So we got already some questions previously about whether I would take a few which were quite interesting, whether we can take mixed language content. So just to clarify that, so we are able, and text-to-speech systems for particular language, we are trying to synthesize the foreign language inclusions, so the most popular words in a given language, and we are catching those words which are most popularly used in the given language. It does not mean that text-to-speech is obviously multilingual. Like every human being, we are focusing on the specific language. So it doesn't mean that single voice can read all the languages. There was a question about SSML, specification and SSML standards. So yes, that's an SSML v1.1, and that's exactly the version which we are supporting. Few other questions which I can see here is any Indian language currently in 24 languages supported? We have Indian English. That's the only language from the region which we have at the moment. Stay tuned. There is a question, please discuss the security aspect of this. So the information is, the answer is, we treat the security very closely at Amazon in general and in AWS as well. So we make sure that all the information which is provided, all the data which is provided is securely processed, and it's secured in transfer and in REST. And other questions which are still open, which we didn't manage yet to answer. I know custom voices aren't supported, but is that something that you guys will look at? Thank you for the feedback. We have the whole backlog of interesting ideas. So again, stay tuned. Definitely interested. Oh, got it. Here I got a kind of joke that we are not able to pronounce some, I guess, random set of letters. Yes, that might be the case. What's the syntax for phonemes? Is it using some sort of standard? Yes. We are for the lexicon. You can use one of two standards. One is called IPA. So that's a standard known specifically for linguists, people who studied linguistics. It consists of some, let's say, non-obvious letters or non-ASCII characters. So it's quite difficult for someone who is not a linguist and is rather a developer. So for developer, there is a kind of equivalent of IPA. It's called XSAMPA, and this is also a standard. So we support both, depending on who is the user of the text-to-speech system. Which machine learning library do you use under the hood? We are using lots of technologies, and everything which fits our needs is used there. What I can tell you is that we are using bidirectional LSTMs for our models. Yeah, we are using some other techniques as well for that purpose. Does Amazon have speech-to-text modules that are in progress similar to Polly? I think that's an interesting question. We got a few of them, of this kind of questions during the webinar. So I would encourage you to take a look on Amazon Lex. That's a service which got released also during this re:Invent in the limited preview. That's a service which leverages the same technology which is under the, or which is used by Alexa. So in general, that's a technology which uses both speech recognition and natural language understanding. So it might be interesting for you. I found that the French voice Céline can test from homepage sounds exactly the same from what is offered on Poly console. Are all the voices actually based on Poly? And you are pointing out to Ivona. Ivona is a result of is a startup which got acquired by Amazon a while ago. So the voices which you can find in Poly, some of them are from, let's say, sound exactly the same because those are the same voices. So good catch. Thank you for that. Is there going to be a Lex webinar? I see that Victoria is answering this. So yes, there will be. There is also a question whether all the voices are based on or the deep learning techniques. I would say it depends. So again, we are using various techniques depending on the needs, and also the languages differ between each other. For some, for example, for G2P, for grapheme to phoneme conversion, for some languages, those languages are that regular, that we does not need any models for that. And Polish is a perfect example. Polish is very regular in terms of pronunciation. So the answer is it depends, not all of them. Are there any plans to add more kids' voices? Again, thank you for feedback and taking this into our backlog. A bonus question, French voice based on Poly, if not, what can we expect, when can we expect it? Is there a French voice based on Poly? Thanks again, great web, thank you. Stay tuned, I'm not sure if I catch the question. We have in fact two French voices, what I can answer to this one. So we have the male and female voice. We are working on the technology still, so stay tuned. Are there plans to add sort of filters to output to distort it, change speech, etc.? We keep working on this. There are already some modifiers like this in SSML. We expect that this kind of questions will come with some more sophisticated ideas. It will be obviously prioritizing, but already today you can use, I guess the prosody tag is the right one, where you can change the pitch, you can change the rate of speech. You can, let's say, for example, define that you would like to put emphasis on some words in the sentence. Just one more question, the last one, sorry about that. Let me choose one. I guess that I answered most of them, so I think we're good. Okay, the last one. You mentioned that you edited the inflections in sentence based on user feedback. How did you contact these studies and elicit the feedback? Fair question. What we are doing lots of kind of crowd tests where we are simply asking users to make the certain, let's say, to provide us information on what they would expect in a particular speech, and then on the basis of this we are building models who are simply learning on this user's feedback. Thank you very much for attending our webcast. I think we are running out of time. Thank you very much. We will try to also answer other questions and address them in offline mode.
Great. Thanks a lot for a great presentation, and I would like to thank the audience for taking the time to join us today. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS will cover in future webinars, please drop us a line at aws-webcast@amazon.com. Your feedback will help us to improve our webinar programming. Thank you again for taking the time to join us today, and enjoy the rest of your day.